Hello, I hope you all are doing well. So today, uh, I will teach you how we can do how we will do a network meta-analysis via frequentist and Bayesian model. Okay, so let me share my screen first. I don't know how to start and from where to start, honestly. Uh, okay. Uh, the first thing is there are certain things about which you should know. Let me open. This is a recent meta-analysis. How are you people able to see my screen? Hello. Okay. So this is this is a meta-analysis, a network meta-analysis, which are comparing different antithrombotic uh, regimens after left atrial appendage occlusion. Okay. Let me show it to you. Here is a in the left atrium. There is uh, I mean, a pouch type place where usually the clots are. I mean, they are usually that's the place of the clot's origin. So different thing. Physician and interventional cardiologist use different things to close that appendage. So we having different things. Now this meta analysis is about saying that when we close that appendage, when we occlude that appendage, right? After that, we need to have some anti-thrombotic therapies, different kind of anti-thrombotic treatments, and we want to know which of the following treatment will be a good option uh, to avoid the device-related thrombosis. To, to do what? To uh, to avoid device-related thrombosis and also major bleedings. Okay, and a lot of other outcomes. And there are different therapies a person can do for this, and there are different therapies uh, physician interventional cardiologists do for this, like dual antiplatelet therapy, dual oral anticoagulant, uh, DOAC plus single antiplatelet therapy, no therapy at all after left. I mean, you load that and no therapy at all, and SAPT, vitamin K antagonist, vitamin K plus SAPT. Right? There are different options, and that's the concept of network meta-analysis. When you are having different options for a single uh, treatment, like right, like here, for example, a patient come to a physician or interventional cardiologist and he occlude the left appendage, and now uh, like physician want to know that which of the following treatment will be good so that the device related thrombosis and major bleeding should be minimum with that, which of the following treatment will be great, right? So this is a genuine question, and this need to be answered, and this can be answered via network meta-analysis, like individual study. Maybe some studies compare this and this, maybe some study compare this and this, maybe some study compares this, right? But a network meta-analysis combine all the arms, and then it shows to you that which treatment effect is good. And there are different plots, different figures, and network meta-analysis about which you need to know. In a single, in the conventional meta-analysis, there was usually one thing which are usually called as forest plot, which are called as what? Which are called as forest plot and forest plot. Okay, forest plot. So in a conventional meta-analysis, there was usually what? A forest plot. And when like here it will be a pooled summary. There is one study, another study, third study, fourth, fifth, and there is a total pooled result of all the studies, and they were all represented in a plot which is called as a forest plot. And before visualizing the data via forest plot, they usually run a meta-analysis via MetaBin or a meta count or a meta prop, meta mean, or a meta gen, right? So by this way, they visualize their data via forest plot. Okay, but in the network meta-analysis, you will see different kind of plots. And the first thing before making a plot, first thing is you need to a basic understanding how to read that plot, right? How to read that plot. Like for example, here if I'm showing you a forest plot, let me show simplest forest plot to you people so that where is that, where is that, where is that, where is that, comparing two things, yeah, this one. No, it's a bit complicated. Where it is, where it is. I think it should be good. Okay, so this is for a plot example 1, 2, 3. This is just, I mean, a good one for a plot, a good forest plot. Okay, component of forest plot. This is really a great description of it. And included studies, outcome in each study. This is the experimental. This is in the control. This is the risk ratio of each one. This is the forest plot, and this is the diamond overall effect diamond, and this is the prediction interval. Okay, the range where the effect size of new random studies would likely fall. Okay, that's called its prediction because it's predicting. Okay, significance of heterogeneity, and this is the this and this. So the thing is that for the conventional meta-analysis, you need to able, I mean, you need to read this thing and understand what mean by this. Like here the ratio is 1.69. From the confidence interval 1.33 2.16. Now if I'm ask you people a question like what does forest plot mean, what you people answer me? There are experimental, there is control, and the risk ratio is 1.67, I think. So yeah, at 1.69, and the confidence interval is purely above the 1. What does it mean? Anyone? Can you people help me understand what this mean? What this pool result mean? What this pool result mean? 1.69, 1.33 till 2.16. What does this mean? Because this is important. If you don't know this one thing, how will you understand a lot of these things? I hope it makes sense to you. This is really important. That's why I'm saying I should have a little bit idea that where you are. Are we on the same page or not? What does this mean? 1.69, 1.33, 2.16. Let me give you options. Option A. Does this mean that the experimental having 69% higher risk of the outcome? Maybe the outcome is mortality. Maybe the outcome is stroke, or whatever the outcome is, and having 69% higher outcomes compared to control. Or option two, control having 69% higher hazards, higher risk of the outcome compared to experimental. Option 3, no difference. Obviously option 3 is not not a good. This is option 1. Like here it is 69% higher risks of that outcome with experimental, 69% higher risk of that outcome with what? With experimental. Okay, yeah. So now when you people understand the basic forest plot, now after that here comes a league table. This is called usually a league table. This is called what? This is called league table. What the league table is and what's it's represent, this is really important to know. Okay, but before the league table, make sure you know network plots. Network plots are network graph. Is this thing, okay, this thing is actually showing how many interventions we have in this network meta-analysis for this specific outcome. So for this specific outcome, we are having 1, 2, 3, 4, 5, 6, and 7. Nodes. This one thing is called node. Okay, and here the sample size of patient contributed to each node. Okay, and here the width of the line represent the number of studies. So no therapy versus this having a very thin line. It means maybe 1 or 2 studies connecting this link, but DAPT versus SAPT after left atrial appendage, maybe highest number of studies contributing to this connecting link. Okay, Let me show the table one if it's no it's in the supplementary file. So leave it. So this is called as what? A network plot or a network graph. Okay. Now coming towards the league table. What the league table mean? I will show you another league table. I mean the actual league table that's usually like this. It's usually like this. Okay. I know that's quite complicated. That's the meta-analysis I shared in the group. Uh, I know this is complicated, but leave it for now. This meta-analysis having what? This meta-analysis having two what? This meta-analysis having, oh my god. This meta-analysis having two triangle. One is the upper triangle, another one is the lower triangle. Upper triangle and the lower triangle. Let me see. There is a yeah, this. Now, if you see here, there are different kinds of intervention. ACI, ARBs, beta blockers, calcium channel blocker, thiazide diuretics, ACI plus ARB, sorry, ACIs plus beta blockers, ACI plus calcium channel blocker, and etc. I mean, having all the interventions at this line, right? At this line, okay. Now, as I said to you people, in this line there are we have two triangle. One is above this line, another is below this line. Now, one thing maybe you notice at the first glance, which is at the upper triangle, there are some cells which are empty. At the upper triangle, there are some cells which are what? Which are empty. Now, first question you will ask, Asad, why is this empty cells in the upper, but no cell which is empty in the lower? I'll come to your answer, and this the a simple answer to this question is the upper triangle as the upper triangle represent direct estimates. Represent what? It represents direct estimates. What mean by this? It mean that, let me show if there let me show if, yeah, okay, can you see this plot? Let me, yeah, dizziness yeah, dizziness is okay. Okay, now if I ask you people in the for the net graph or the net plot for the outcome of dizziness, how many nodes we have? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 and I think 18, I think. Okay, so we are having these nodes, right? But now if I ask you so ARBs versus placebo having a very thick line, and calcium channel blocker versus placebo also having a very thick line. Now if I ask you, is there any line connecting ACI plus THZ and ACI plus OTH? Is there any line connecting these two things? Huh? Is there any line? No. Is there any line connecting ARB and these things? No. So here is the concept of direct and indirect estimates. Direct estimates that there are some studies, maybe I don't know, maybe 5 studies, 10 studies, which are directly comparing these two things. So their pooled results will be called as direct estimates. Okay, but there are no such studies which are comparing these two arms, these two nodes. So in the network meta-analysis, we will got their effect. Let me explain it to you. Let me explain it deeply. Like here you can see FO. Here is option A, node A. Here is node B, and here is node C. Okay. There is, for example, 2 studies comparing A versus B. Okay, and 2 individual studies. And there is also we are having, let's say, 3 studies comparing A versus C. Now you will have a pooled result of B versus A, and you will have a pooled result. Okay, you also have a pooled result of A versus C. Okay, but this is the I mean, this is the advantage of network meta-analysis, that it will also produce some effect estimates of B versus C. Okay, maybe in a maths, you people have study a property called transitive property. Now, if I'm saying that A is equal to B, and then I'm saying that this A is equal to C, that's mean uh, BC is also equal. So if there is equal, so if they are equal, so that's why in a network meta-analysis your studies, I mean, that's non-negotiable. Your studies should be very similar population. That is why that is the concept of transitive property. A is equal to B, and then A is equal to C. It means B is equal to C. So we have this direct relationship. This direct relationship, that's called direct evidence. That's called direct evidence, and we can get the indirect evidence of B versus C. Yeah, we can get that, the indirect evidence. That is why we are having comparing these things and all of these things, and we can get these things too. But in a in a net league table, the upper triangle, the upper triangle only report the direct evidence, where the studies do not having the indirect, I mean, do not have the direct evidence. That's empty. While the lower triangle reported both direct plus oral estimates. I mean, direct plus indirect. Okay, so that's why there is no empty cell. And the same thing is written here, that in the upper triangle, direct estimates are row versus column. What does this mean? I'm explaining to you. And in the lower triangle, network estimates, I mean direct plus indirect. Okay. Now you will ask me, that's what I mean by here in the lower triangle there are column versus row, while in the upper there is a row versus column. I mean, what's mean by that? Okay, I'm explaining it to you. Let's say we are looking at the lower triangle, and there are, for example, direct estimate of, let's say, leave the direct estimate. Okay, let's go to the direct estimate. ARB plus calcium channel blocker versus placebo. I mean, now they are comparing two things via direct estimates and say, like, what's their direct estimate? So the direct estimate is, they're comparing what? Let me make it yellow. Yeah, yellow is okay. ARBs, aldosterone receptor blocker plus calcium channel blocker versus placebo. Okay, so first look at in the diagonal, you have all the treatments. So look for what? Look for ARBs plus CCB. Okay, so this is ARB plus CCB. Okay, and then where is placebo? And this is placebo. And now you are looking for what? You're looking at the direct estimates. Where will you find the direct estimate? At the upper triangle. At what? At the upper triangle. Okay, so at the upper triangle, so this is ARB plus calcium channel blocker, and in the upper triangle here, this is something, and this is placebo. So actually this point estimates are for ARB plus calcium channel blocker versus placebo, and the direct estimates. And the what? And the direct estimates. So that's mean by row versus, let me see what's notification is. Admetron. So that's mean by row versus column. Okay, row versus what? Row versus column. Okay, now for the lower triangle, which are indirect estimates, I mean the whole estimates, the network estimates, you will do what? You will column versus the row. So the column of ARB plus calcium channel blocker, and that's this column. Okay, that's column, and you will, where you will stop? You will stop at the row of the thing you're comparing it to. Now let me ask you this question and that graph. Now you understand. Now there in this network meta-analysis, they only reported what? The network estimates. I mean the whole estimates. I mean the direct plus the indirect. Okay. I mean that they did not here also report the, I mean only the direct estimates. They did not report that, and that's not compulsory to report it too. Okay. So now, if here, let me ask from you people. Let me ask from you people that uh, let's say we are comparing no therapy. Let's say we are comparing what? We are comparing no therapy and VKA plus SAPT. So, what will be their relationship? I mean, what will be its pooled? Let me see what's it. Where is the yeah? That's OR. I mean odd ratio. That's what. That is not risk ratio. I mean that's what. That's odd ratio. So now if I ask you people, what will be the odd ratio of no therapy versus no therapy versus VKA plus single antiplatelet therapy? What will be its odd ratio? So what you will do is, remember, this is a lower triangle. Okay, this is the lower triangle. Lower triangle report what? Both estimates. Okay, and now if it is both estimate, you will do what? You will column versus the row. So no matter what you are comparing, you will just go with the column versus the row. So what's its point estimate? Its point estimate is no therapy related for the outcome device related thrombosis related to VKA plus single antiplatelet therapy as like the odd ratio of 2.24, the confidence interval from 0.59 till 8.57. Now, my question from you people is, let me ask you people a question. Okay, please listen, everybody. I need answers from you now here because this is really important. My question is here the device related thrombosis reduced. Look at this number. Look at this number. Device related thrombosis reduced with no therapy compared to VKA plus SAPT R. Increased with no therapy compared to VKA plus SAPT R. No difference between the device related thrombosis if you give no therapy, I mean not treat at all, or you give it VKA plus SAPT. Please answer me. Hello? Hello? Am I talking to boots? Hello? Am I audible? Hello? Hello? The odds ratio is great in no therapy. No, who replied that? Roman. Decrease with no. Hamza saying, oh my god, they're genius. Look at this. First, please. We do not mean decide on the basis of just odd ratio, just its value. We also look at the confidence interval. Please look at it's from 0.59 till 8, 0.59 till 8. So wide confidence interval crossing the line of null effect. I mean line of 1. Significant? Not significant. No significant difference if you treat the patient with, I mean, do not treat it or treat with VKI plus SAPT. Do people understand what I am saying? So there's no difference. There is no difference. Honestly, I feel a little bit okay. So my next question from you people. I think the question is are really important. So here, if you look at the confidence interval, it's from 0.59 till 0.8 until 8.57. So this means this is a huge confidence interval that represent there is no significant difference between no therapy and VK plus SCPT in terms of this outcome. Okay, in terms of what? In terms of this outcome. Okay. Now, my next question from you guys is is what's the odd ratio of dual antiplatelet therapy and no, sorry, dual oral anticoagulant therapy versus no therapy. I mean, if you treat a patient with DUIC or no therapy at all, what will be the device related thrombosis effect? I mean, what should I do? What should I do? How can I read this league table for for uh, mm, to know about how these tools are related? What should I do? How should I read this league table? How should I read it? What will I do is I will from column to the row of the thing I want to compare. So it's 0.36. Now my question, second question from you people is, when you look at what you are comparing, when you look at what you are comparing, after that, is this comparison statistically significant or not? So if you look at the confidence interval, it's purely under one, right? That's mean the this means it's statistically significant. But now my question from you people, is it favoring DOIC or it's favoring no therapy? Obviously, it's saying the odd ratio of device-related thrombosis with DOIC is 0.36. What does this mean? It's mean at reducing the odds of device-related thrombosis. How much percent? It's 36, so that would be 64. 64%. The odds of device-related thrombosis reduced with DOIC compared to what? Compared to no therapy. Compared to what? Compared to no therapy. Do you understand what I mean? Now, another question is, for example, you're comparing DPT, DAPT with what? With VKA, and you want to know what's their effect estimates uh, for the outcome of device-related thrombosis. How will you do it? You will just go column and to the row of the thing you are comparing to. So what's their effect estimate? Odd ratio at 0.99, it's from 0.45 till 2.16. So my first question is the effect estimate significant? No, because the odd ratio confidence interval crossing the line of null effect, it's from 0.45 till 2.16. So in between the two things, there is the line of null effect, which means if it's cross it, so no specific significant difference in the device-related thrombosis between DAPT and vitamin K antagonist. Okay, for the outcome of device-related thrombosis. So that was all how you can read a league table. So till now, I describe a net graph, a league table with you people. Now let's say what's remaining. Now let's say what's remaining. Now there is another thing called direct evidence plot. What's called is direct evidence plot. I know maybe you feel a little bit difficulty in understanding this, but it's okay. I'll help you. Yeah. Yeah, this is the plot which is called as, what is this plot called? This plot is called as a direct evidence plot. What mean by this? This plot shows us, I mean, for a specific comparison, let's say dual antiplatelet therapy versus single antiplatelet therapy, how much percent we have direct evidence and how much percent we having indirect evidence. Let me show it to you for the major bleeding. Here is the major bleeding. The combined rate, yeah, I think it was in the full text. Yeah, here it is. Here, SCPT versus this, and also, no. Like, if you look at this, this is uh, dual anti oral anticoagulant, this, and now this. Let me redo this. Give my, please, please concentrate. Okay, see this. This is what comparing two things. DOAC plus SCPT. Oh my god. Yeah, let me see what I'm concentrating on. DAPT versus SCPT inherits. Yeah. So DOAC versus SCPT. I mean, we have some studies comparing these two. Okay. Now also we have some studies comparing these two. It's like A, it's B, and it's C. Now, if I'm saying like some studies comparing AB, now some studies comparing AC, so can we have an indirect comparison originated, which we got from directly comparing these two? Huh? Yes, of course. We can have an indirect comparison. We can have it. Another thing, see this. This is a direct. This is another direct. Can we have a direct evidence? Sorry, indirect evidence. Yeah, we have. That's the concept of direct and indirect evidence. That's the concept of direct and indirect evidence. For the comparison of DAPT versus SAPT, if you look at the majority of the line is yellow, and of course this must be yellow, because if you look at this, line, that's so thick, the black is so thick, it means we even having a lot of studies comparing DAPT versus SAPT, and this line should be more thick than any of the line here in this plot. It's more thick. I mean, it's more wide than any of the line is this in this net graph. Okay, that is the reason. That the direct evidence, I mean the yellow color here, it's more. Even I think it's more than 75% for this comparing two things, DAPT versus SAPT. After that, followed by what? Dual oral anticoagulant versus vitamin K antagonist. I hope you got my point. So this is a plot which shows that for comparing each arm, how much of the evidence we got, from the direct comparison versus from the indirect comparison. Now, if you look at this evidence, this for the device related thrombosis. This for the what? That's figure is for what? That's for the device related thrombosis. Okay. Now, for the device related thrombosis, if you look at this thing, VKA, vitamin K antagonist versus vitamin K antagonist plus SAPT. Now look at now. Let's say we are going back to its. Let me show it to you this way. For the outcome of device related thrombosis, look at this. What's this? This is VKA. Here is your VKA. Let me click the pen. Here is VKA. This is VKA. Okay. Now versus, what's versus? VKA plus SAPT. Now here is VKA plus SAPT. My question from you people, is this two connected? No. Now, when they are not connected, then it simply means that we do not have a direct evidence comparing these two. We do not have direct evidence. So all the evidence comparing these two will be comes from what? It will be comes from indirect evidence. And here you can see in this plot that the full line here is blue. I mean, the evidence come from the uh, indirect relations, indirect evidence. Okay, so what's this plot called? Direct evidence proportion for each network estimate. There are different network estimates, and there are percentage that how much direct evidence contribute, how much indirect evidence contribute. So it's good when for specific comparison, when more of its uh, I mean contributed, I mean reported by direct evidence, that's good, that's reliable, that's valid. I mean that's a really good thing. When it's wholly solely reported by the indirect evidence, then in that case, what you need to do is uh, then in that case you need to interpret this relation with caution, with little care. Okay, that is the reason when you having two things. I mean, let me give you another example. When you have this situation, when you have this situation in which this is having A, this is having B, and this is having C. This is a lot of study comparing these two, a lot of study comparing these two, but but you have no study comparing the B versus C. That usually happen. Like here is a placebo, here is this, there is one arm, there's another arm. This I'm comparing with placebo, this I'm comparing with placebo, and but there is no study comparing this. Then obviously the whole amount of evidence you got for these two, that will be from indirect, and that will be wholly solely blue. And the blue line comparing B versus C, how will it look like? It will look like this. Here it will be B, and here it will be versus C, and the line will be completely blue. And the estimates, network estimate which you got from this, that will be, I mean, the evidence will be poor. That simply means like the evidence from observational study, while the yellow simply it's like evidence you got from a randomized control trial, which is having more value. I hope you got my point. So this was second thing, which is called evidence, uh, direct evidence proportion. Okay, plot. I hope you got my point. Let me know if there is confusion up till now regarding net graph, regarding G table, or regarding the other direct evidence plot. Okay, okay. Now, if you look closely, here in the direct evidence plot, there are two columns more. One's called minimal parallelism, others called mean path length. What this mean and what the significance of this, that's important. If you look at the mean path length, here there's a vertical line at the two. Remember, let me explain you the mean path length. Let's see, we are comparing two things. Let me draw a figure for you people. Let me draw a figure for you people. Where can I draw a figure? Oh my god. Oh my god. Okay, look at here. Just look at here. There's for example A, there's for example B, there's for example C, there's for example D. Okay, that's D. Now we having one path, it's a direct path. We also having another path, it's indirect path. We also having another path, which also indirect path. So where that is. So mean path length. When the mean means average path length, when it's more than 2, that means you need to interpret that with caution. Okay, because that really having a lot of evidence, and you need to interpret that with caution. This is line one path. This is uh I mean one path, and this up we having two paths, and then we having another uh, uh two two bridges. Okay, and we having a total of 3 routes, and if we want to know what will be the total, it's 5 divided by 3, it's what? I did something like this. So minimal, let me, where is it? Yeah, mean path length. Average hopes more than 2, heavily indirect, read with caution. So if you look at this, for each the comparison where it is more than 2, that's why the vertical line we have. When it's more than 2, you need to interpret that relation, like for this, like for this, like for this two, for this two, for this two, for this two. You need to what? You need to do what? You need to interpret that with caution. Okay, this just mean this. Okay, what's mean by minimal parallelism? Minimal parallelism means how many independent routes feed that estimates. More is okay. How many independent route that feed estimates? Like here, for example, DAPT versus SAPT. Like how many average routes going to this? Like if I ask you people this, like how many routes these relation estimate? There is 1, there is 2, and there's 3. So 3 routes. So that's the concept of minimal parallelism. How many parallel line going to that? I mean, with that independent routes for that specific relation. So these two column means this, and these two column usually presented in the direct evidence plot along with the proportion of how much a direct evidence contribute to a network. Okay, mean path length more than 2, that's not good. Okay, now let's proceed with the net heat plot. It's a bit complicated in a sense. I mean, let me uh, I mean um like first you understand the league table. Like what league table show? It compare different strategies, and their whole estimates are directly written there. Okay, at having upper triangle, at having lower triangle. Lower triangle is good because it having all the estimates. Upper triangle having only direct. Okay, after that direct evidence, how much each having contributed by direct and how much from indirect. Okay, after that you need to interpret whether you having inconsistency, I mean heterogeneity among studies or not. For assessment of heterogeneity you need two things: net heat plots or not net splitting. Net splitting, as I said to you that I said to you that, for example, if you look at this, the DIPT versus SAPT, about 70, about more than 75% you got this by direct, and less about 10-15% you got by indirect. So there are some estimates which you got by direct, some estimates which you got by indirect. Now you want to know whether the indirect estimates are really good to believe on that or not. I mean, can you believe that? Can you believe those estimation? So like it's like, let's say A is DAPT, B is SCPT, and we are having a confidence interval on the with the odds ratio at the direct estimates, and we also having this blue one from we got some values from the indirect estimates. And Here you will have a p-value, and that p-value will describe whether there is a significant difference from the direct and from the indirect evidence. If there is a significant difference, it means that your indirect thing is not reliable. Like here, in the case of A versus C, the direct is there, I mean, and the indirect is showing no difference, and that's why the p is significant. That what does this mean? This means they disagree. So the pooled network estimates is hiding inconsistency at that node. There is some inconsistency. Okay. So that's the concept of net splitting. I mean, split the network to its direct evidence and its indirect evidence and see if their direct and indirect evidence relate or not. If they relate closely, that's okay. You can trust this relation. If they disagree, I mean, there is some inconsistency. So you can write in your report report and result section like this: direct and indirect evidence agreed for most comparison. A versus C differed, and the p-value is significant. Okay. Same is the case with the net heat plot. That's actually when you're having a gray color for specific comparisons. That means they are having a consistency. They're having no conflicts. But if you look at the A versus C, they're huge colored. So the colored points are actually the conflicts. This is a very simplistic diagram with simplistic explanation. Okay. Now, after that, ranking with p-scores. Estimated, trusted, and consistency checked. I mean, you check the, you first see the leak table, the lower is from the network, the upper is from the direct, and you see if there is enough consistency, and you can trust the direct and indirect relations. And now you need to you need to rank the treatment. I mean, which one is better? Obviously, if you are comparing these multiple options, I mean 7, 1, 2, 3, 4, 5, 6, 7. So which one is good among them? Which one is second good? Which one is third good? Right. You need to rank it. So for the device related thrombosis, this is a p-score for each antithrombotic strategy and endpoints. So for DRT, I mean device related thrombosis, the DAPT having a p-score of, I mean the highest p-score. No, sorry. My mistake. The highest p-score is for this one. Dual oral anticoagulant plus single anti-platelet therapy, and that's the p-score with the highest one. The p-score range from 0 to 1, and the more it's high, the better it is. So highest for this has been this arm is really good for device related thrombosis, but for another outcome, for each outcome you will have your separate p-scores. For each outcome you will have your separate what? P-scores. Okay. Here you can see for each outcome you can rank, like this is the first term. After children, this is short. This is second. This is 3, and this is 4. I'm just saying for the DRT, not for the whole. 4. Hopefully that yes. So this is a 5. This is 6. And this is this is 7. I mean the last one. Okay. Okay. Now we have I hope you understand what mean by p-score and what's it represent. Okay. But there is one thing which I will show you in the analysis. Sometimes you need to set whether the p score, I mean the lower effect estimate is good or higher effect estimate is good. I know you will not understand this now, but in the analysis you'll look at it. You'll look at that. Okay. There is one thing remaining. Yeah, for the net split, which I was talking about, it's this. You can see here the evidence from the direct estimates. If you look at this is from the direct estimates. If you look at this, the confidence interval crossing the line of 1, so that's why this value is a negative, I mean minus 0.49, but this above 0, so it's 0.83. So the confidence interval is what? If you look at this in the odd ratio of 0.06, and it's more than 2.29. So I mean, that's the direct estimate, this is the indirect estimates, and there is no that much heterogeneity between direct and indirect estimates. So you can trust these results, the result of the network. You can trust the result of the network, because if you look at the direct estimates, that's not significant. I mean 0.62 till 2.29. If you look at the indirect, that's from 0.46 till 5.12. Okay. And if you look at the network, that's also non-significant from 0.71 till 2.2 to 2.24. So when they are closely related with each other, that's called consistent. Okay. There's one thing remaining, which is called what? Which is called, yeah, it's called ranking probabilities are rankogram. Ranking probabilities are rankogram. Okay. What do you mean by this? That means that's what is the probability. I mean, we have 7 nodes, right? We're comparing what? We're comparing 7 different things, okay, for one population, which for the left atrial appendage occlusion, okay.